This is the week 8 video, exponent rules. Here we have an example of a base and an exponent. The x is our base, and the a is our exponent. The first rule we're going to talk about is the product rule. That's when you have the same base and it's a multiplication problem. So for instance, we have x to the a times x to the b. What you do to solve that is you keep the base, you're going to add the exponents, and you're going to multiply the coefficients if there are any. So your answer for this problem would be x to the a plus b power. Our first example is a to the 4th times a to the 6th. Our base is a, so we're going to keep our base, and we're going to add our exponents, which are 4 and 6. We get a to the 10th power. The next example is 6 squared, or 6 to the 2nd power, times 6 to the 5th power. We're going to keep our base, and we're going to add our exponents. We get 6 to the 7th power. Our next example, we have coefficients. We're going to do the same thing with our base, which is x to the 4th. And remember, if you don't see an exponent there, it is a 1. So our base is going to be x to the 4 plus 1. And we're going to multiply our coefficients, which are 4 and 5. So we're going to multiply 4 times 5. That gives us 20. We have our base x, and we have our exponents, 4 plus 1, which is 5. Our last example for this rule, our first base is x squared. We have another x over here, which is to the 1st power. Our y has a 4, and over here a squared, so 4 plus 2. And we also have our coefficients to multiply, which are 3 and 2. So we end up with 3 times 2 gives us 6. Our x has an exponent of 3, 2 plus 1. And our y has an exponent of 4 plus 2, which is 6. Our second rule is the quotient rule, which is a fraction or division problem. You have two terms with the same base. One's in the numerator, one's in the denominator, a fraction or division problem. The way that you solve this one is you keep the base. This time we're going to subtract the exponents, and we're going to simplify the coefficients, or divide. So in our example, y to the a power over y to the b power, that would be y to the a minus b. So our first example is a to the 6th over a to the 4th. So we're going to keep the base, and we're going to subtract our exponents. They are 6. We put the 6 first, minus 4. 6 minus 4 is 2, so our answer is a to the 2nd power, or a squared. Our second example is 7 to the 4th over 7 squared. We keep the base, which is 7, and we subtract the exponents. 4 minus 2. Always put the numerator on first. So we get 7 to the 2nd power. 4 minus 2 is 2. Our next example has coefficients, which we're going to simplify. So find a number that goes into both 9 and 6. I'm going to use 3. So we're going to divide those both by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. So we have a fraction as an answer. Our numerator has a 3 in it. Our denominator has a 2. And we're going to subtract our exponents, y to the 5 minus 2, which gives us y to the 3rd power. That goes in the numerator. Y to the 3rd over 2 is our answer. And the last one, again, we have coefficients to simplify. So we're going to simplify 12 and 4. We're going to divide those both by 4. 12 divided by 4 is 3. And 4 divided by 4 is 1. X to the 7th over x squared. So we're going to have x to the 7 minus 2, which gives us x to the 5th. Again, that goes in our numerator. And we also have a y. We have y to the 5th power over y to the 3rd, so it's going to be y to the 5 minus 3, which equals y squared. That goes in your numerator. The only thing we have in our denominator is going to be the 1, which we don't need to write. The 3 is our numerator. The x to the 5th is our numerator. And the y squared is our numerator. So it is 3x to the 5th y squared. The next rule is the power rule. This is the first of 2, which is a power raised to a power. So we have a to the x, and then that is raised to the y power. The way that you solve this is you keep the base, and now we're going to multiply the exponents together. So the base remains a, and we multiply x and y together, and that's your exponent. So our first example is a squared raised to the 3rd power. We're going to keep our base, which is a, and we're going to multiply the exponents together. 2 times 3. 2 times 3 is 6, so our exponent is 6. We get a to the 6th power. For the next one, our base is 6. We're going to keep the base. And our exponents are 5 and 2. So we're going to multiply together 5 and 2. 5 times 2 is 10. So we get 6 to the 10th power. The next one is x to the 4th power, which is raised to the 2nd power. So our base is x. Our exponent will be 4 multiplied by 2, which is 8. So our answer is x to the 8th power. And our last one, remember, if you don't see an exponent, there's really a 1 there. So this is y to the 1st power. Rule, this should say 2. Please change that to 2, which is a product raised to a power. So a product means we're going to have 2 things inside of our parentheses instead of just 1 like the first one. The way that we do that is we're going to distribute the exponent to each part of the base. And then we simplify. So example number 1, we're going to distribute our exponent of 2 to the a and also to the b. So we get a to the 2nd power, b to the 2nd power. And that's your answer, a squared, b squared. Example number 2, again, we're going to distribute our exponent of 2 to the 4 and to the y. So we get 4 to the 2nd power, y to the 2nd power. We can evaluate 4 squared. 4 times 4 is 16. And then we have y squared. Number 3, we're going to distribute or give our exponent of 4 to every term inside. So the 6 and also the m. So we get 6 to the 4th power and m to the 3. Make sure you remember that this is multiply times 4 because they're in the parentheses and outside of the parentheses. So we have 6 to the 4th power and then m to the 3 times 4, which is 12. And the last one, again, we're going to distribute or give our exponent of 3 to everything inside our parentheses. So the 3, so 3 to the 3rd power. We give it to the x squared. So x squared to the 3rd power, which would be times 3. And then y to the 4th power raised to the 3rd power, so also times 3. 3 to the 3rd power, we can evaluate that. That's 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. We have x to the 2 times 3, so x to the 6th. And we have y to the 4 times 3, so y to the 12th. Negative exponent rule. What you have is a base raised to a negative exponent. For instance, a to the negative m power. The way that you solve these is you first remove the negative sign, and then you move it to a denominator in a fraction. If there's nothing for a numerator, you're going to use 1. This also works for those terms with a negative exponent that are in your numerator. For instance, a problem like that. So the first one we have is x to the negative 3rd power. We're going to remove the negative, and it's going to become our denominator. So our answer is 1 over x to the 3rd power. The second one is 3 to the negative 6th power. So we're going to remove the negative, and we're going to use it as a denominator, and we're going to put 1 as our numerator. So number 2 is 1 over 3 to the 6th power. Our next one, number 3, we have x to the negative 4th power, y squared. Start with x to the negative 4th power. We're going to remove the negative, and it's our denominator. Y to the 2nd does not go in the denominator because it doesn't have a negative, so it's going to stay or go in the numerator. So we have y squared over x to the 4th. For number 4, anything with a negative exponent is going to go in the denominator without the negative sign. The first one is x to the negative 2nd power, so we're going to remove the negative. So that one's x to the 2nd power, and it's going to be in the denominator. We also have z to the negative 4th power. We're going to put that in the denominator and remove the negative. Whatever we have left is in the numerator. So we have a 5, and we have y to the 3rd. So our answer is 5y to the 3rd over x squared z to the 4th. Our next rule is negative exponent rule number 2. This is when the denominator is a base raised to a negative exponent. And this works for any terms in the denominator that have a negative exponent. So what we're going to do is first you remove the negative sign just like before. And now we're going to put our term in the numerator. So we're switching its place. If we have nothing left in the denominator, or there's just a 1 in the denominator, you do not need to make it a fraction. You're going to remove the fraction bar and the 1. So our first example, number 1, is 1 over a to the negative 4th power. So we're going to remove the negative, a to the 4th power, and we're going to move it to the numerator. So it becomes a to the 4th over 1, because we have nothing for a denominator. In that case, we do not need to write the fraction bar or the 1, so it's just going to remain a to the 4th. For number 2, our negative exponent is 4 to the negative 2nd power. We're going to remove the negative, and it's going to go to the numerator where we already have a number. We already have a 3 in our numerator, so we need to keep that there. Again, since there's only a 1 in the denominator, we don't need the 1 or the fraction bar. So we have 4 squared times 3. 4 squared we can evaluate. 4 squared is 16. times 3. And we can do 16 times 3 and get 48. Our next one is number 3. We have 4c squared in our numerator, and we have 5c to the negative third power. So we're going to focus on our c to the negative third. We're going to remove the negative, and it's going to move up to the numerator with 4c squared. In the denominator, we still have our 5, so we're going to leave that as a denominator. We can simplify our numerator a little bit here. We have c to the third power and c to the second power. If you remember from our product rule number 1, we take our base and we add the exponents. So we end up with 4c to the 3 plus 2 power over 5. So our answer will be 4c to the 5th power over 5. Our last one is number 4. We have a 3 and a 15 we can simplify. We're going to find a number that goes into both 3 and 15, which is 3. So we're going to divide them both by 3. 3 divided by 3 is 1, and 15 divided by 3 is 5. We need to take our negative exponents, x to the negative third. That's going to become x to the third power, and it's going to move up to the numerator. So let's start our fraction. We have a 1 in our numerator. We have an x squared in our numerator. And we have a y in our numerator. In our denominator, we have a 5. We have our x to the negative third, which we're going to remove the negative and place in our numerator, which becomes x to the third. We have our y to the negative second power in our denominator. We're going to remove the negative and place it in the numerator. And also in our denominator, we have a z. Since it doesn't have a negative, we can't move it. We're just going to leave it in the denominator. And now we can simplify our numerator. We don't need the 1, so we can get rid of the 1. And we have x squared and x to the third. Our product rule says we're going to add those exponents together, so that gives us, in our numerator, x to the 2 plus 3, so x to the 5th. And we also have y and y squared. Remember, there's a 1 exponent, so we're going to have y to the 1 plus 2, which is 3. And then in our denominator is going to remain 5z. 5z. Make that a little bit bigger there. So our answer is x to the 5th power, y to the 3rd, over 5z. Which is anything to the 0 power is equal to 1. So anytime you get something that's raised to the 0 power, or your exponent becomes a 0, that's going to equal 1. So g to the 0 power equals 1. Number 1, x to the 0 power equals 1. Number 2, negative 14 to the 0 power equals 1. Number 3, we have negative 24x squared y to the negative 5th, and that is raised to the 0 power, which is 1. Our last one is a little different. If you recall, we subtract the exponents when they're in a fraction. So we have x to the 4 minus 4. 4 minus 4 is 0. And we have y to the 2 minus 2. 2 minus 2 is 0. So we have 1 times 1. Finally, we're going to do 4 problems where we combine the rules together. So example number 1, let's start with the numerator. We have a product raised to a power. So if you recall, we're going to distribute our exponent of 2. We're going to distribute that to the 3, to the x squared, and to the y to the 4th. So that gives us 3 squared x squared to the 2nd power, which means multiply, and y to the 4th power squared, which again we multiply. Our denominator, we're just going to rewrite x, y squared. Let's evaluate these. We have in our numerator 3 squared, which is 9. We have x to the 2 times 2, so x to the 4th. And we have y to the 4 times 2. 4 times 2 is 8, so y to the 8th over x, y squared. We can now use our quotient rule, which is to subtract the exponents if there's a matching base. So we have x to the 4th over x to the 1st. So we're going to subtract 4 minus 1, and we get x to the 3rd power. And we have y to the 8th over y squared, so we're going to subtract 8 minus 2. 8 minus 2 is 6, so we have y to the 6th. These ones right here, since there's no negatives, we keep them in the numerator. So for our numerator, we have 9. We have x to the 3rd, and we have y to the 6th. We have nothing left in our denominator, so we're going to erase our fraction bar. It's no longer a fraction. And this is our answer. 9x to the 3rd, y to the 6th. Number 2, we have 2x squared z to the negative 2nd in our numerator. In our denominator, we have x to the 4th. If you recall, we're going to remove the negative, and we're going to move it. So it's going to go down into the denominator, and it's going to become z to the positive 2nd power. Okay, we always remove the negative sign and switch its place. So in our numerator, we still have 2x squared. In our denominator, we have x to the 4th, y, z to the 5th, and we also have our z squared. Since we have a z to the 5th and a z squared, we're going to use our product rule, where we're going to add those exponents together. So that becomes z to the 5 plus 2, which is z to the 7th. We also can look at x squared and x to the 4th. X squared over x to the 4th means we're going to have x to the 2 minus 4. X to the 2 minus 4 is going to be x to the negative 2nd power. That's going to go in our denominator without the negative. So all we have left in our numerator is our 2. In our denominator, we have z to the 7th, x squared. We always want to put them in alphabetical order, so our answer is going to be 2 over 2 over x squared z to the 7th power. Number 3 is a multiplication problem. First, we need to distribute our 2 using our power rule. 2 is going to go to the 6, so we have 6 to the 2nd power, or 6 squared. And then we have m, that's to the 3rd power, that's going to get the 2 also. Remember, we multiply. That gives us 36, 6 times 6, m to the 3 times 2, which is 6. And to that, we're going to multiply by 4m to the 4th power. First, we're going to multiply our coefficients. 36 times 4. 36 times 4 is 144. And we have m to the 6th times m to the 4th. We're going to add those two together. We get m to the 6th plus 4. 6 plus 4 is 10. So our answer is 144 m to the 10th power. Our last one, if you'll notice, the entire thing is raised to the 2nd power. So we have to distribute our exponent of 2 to everything in the numerator and the denominator. So we're going to give it to the 3. So that's 3 squared. We're going to give it to the a squared. So a squared times 2. And we're going to give it to the b to the 4th power. So that's b to the 4th times 2. That's our numerator. We also have to distribute our exponent of 2 to the denominator. So it's going to go to the 12. So 12 to the 2nd power. It's going to go to our a to the 3rd. A to the 3rd times 2. And it's going to go to our b. B to the 1 times 2. Okay, let's evaluate some of this. We have 3 squared, which is 3 times 3, which is 9. We have a to the 2 times 2. 2 times 2 is 4, so we have a to the 4th. And we have b to the 4 times 2. 4 times 2 is 8. In our denominator, we have 12 squared, which is 144, 12 times 12. We have a to the 3 times 2. 3 times 2 is 6, a to the 6th. And we have b to the 1 times 2, which is 2, so b squared. If we have a's in the numerator and denominator, we're going to need to subtract. We have a to the 4th over a to the 6th.